This is basically a right strobe. This strobe indicates which byte lanes to update during a write transfer. There is one write strobe for each bits of write data bus. For example, if we in a 32 bits packet, that is we have 4 bytes. In a 32 bits data packet, we have 4 bytes. This is byte 1, this is byte 2, this is byte 3, and this is byte 4. So for each byte, we have one strobe signal. Here we have one strobe signal. For second byte, we have another strobe signal, and for third byte, we have another strobe signal, and fourth byte, we have another fourth. So for 32 bits, that is for 32 bits of data or 32 bits of packet, we have 4 strobe signals like this. So each strobe signal indicates that whether the bridge can transfer data to the particular byte lane or not. So if this strobe signal is equal to 0, then the bridge will not transfer data to this byte lane. If this strobe signal is equal to 1, then the data will transfer to this byte lane. Like this, the bridge will know which byte lane the data should be transferred. Consider this as a bridge, and the bridge is sending data to the APB interface, and here we have an AHB interface, and the AHB interface is sending data to the bridge, and bridge is sending data to the APB interface. So let's say the AHB interface is sending data, that is 32 bits. This is one set of information, and again it is sending another 32 bits of data. So this is a packet, and this is another packet. So in a packet, we have 32 bits of data. That is, we have 4 bytes. This is first byte, that is 0 to, this is first byte, that is 0 to 7 or 7 down to 0, and this is second byte, that is 15 down to 15 down to 8, and here we have 23 down to 16, and next we have 32 down to 24, 31 down to 24. So here 0 to 31, that is 32 bits. Like this, if we divide it into bytes, we have 4 bytes of data. 4 bytes of data. So for every byte, we have a strobe signal. So for this first byte, we have a strobe signal P strobe of 0. This is the first byte, and here we have P strobe of 1, and here we have P strobe of 2, and we have here P strobe of 3. So total we have 4 strobe signals in the case of 32 byte data. So here we have 4 strobe signals. So if what happens if P strobe is equal to 0, P strobe of 0 equal to 0, then it indicates that the bridge cannot send data to this particular byte lane. So here if also it sends the data, this particular byte lane will be invalid if it is equal to 0, and if P strobe of 1 is equal to 1, then this particular field is equal to this particular byte lane, the data which is available in this particular data byte lane will be equal to is valid data, and similarly if it is 1, then it is valid or else it is invalid. similarly following by p strobe of 0. Generally, p strobe is an optional signal. So with the help of this p strobe, we will decide, the bridge will decide which byte lane is valid or invalid. Now, p ready. P ready signal is out, sorry, here it is mentioned as input, but p ready is an output signal from the APB interface. P ready signal is an output signal from the APB interface. P ready is used to extend an APB transfer by the APB interface. Generally, we have also already seen our H ready signal in AHB. Similarly, P ready signal is also used to indicate the status of A- uh, our APB interface. If P ready is equal to 0, then our interface is not ready for any kind of transfer. It is still performing previous operation. Whereas if it is equal to 1, then it is ready for accepting or sending the data. PR data. PR data is the read data bus through which the APB interface sends the data to the bridge. So PR data is output for our interface. And p slave error. P slave error is used to indicate any transaction error associated. P slave error is an optional signal and can be asserted high by the interface to indicate an error condition in the transfer. And p wake up signal indicates any activity associated with the APB interface bridge. This is an input for our APB interface. Bridge sends this p wake up signal to indicate any activity associated with the interface. And PA user request attribute, and PW user write data attribute. And coming to PR user, it is a user response attribute. And PB. So yeah, we are not going to discuss these three signals mostly, so I'm not focusing on the signals more. Just to know, these are the user attribute signals. So these are the signals associated with our APB interface. And the protocol APB interface is called as completer, and the data which is sent to this completer is our bridge. It is called requester. So these are the terms associated with this.